We have so much time. All right, the height of a trapezoid. We're talking about trapezoids, rhombuses, and kites today. The height of a trapezoid is the perpendicular distance between the bases. So you could see a trapezoid like this. Oh, that's not exactly how I drew my one in there, but that's okay. All right, and then the two parallel sides, those are always the bases. The two parallel sides. So B1, B2, it doesn't matter which one you make B1 and B2. It makes no difference. This one, I'm just going to draw the height like this. It has to be perpendicular. Sometimes it'll be this side. Sometimes it'll show you over here as well. I just don't know if that's exactly perpendicular, but that's what it looks like. Has to be perpendicular between the two bases. Easy enough. Does anybody remember the area formula for trapezoid? What goes inside here? Do you remember?
Base 1 plus base.
Right on. Times what? That's it. Add the two bases, cut it in half, and multiply by the height. Easy way to look at it. Cut the height in half, multiply it by the two bases added together. It's all multiplied, so you can do it in any order. All right, area of a rhombus. So what do we know about a rhombus? The sides are equal, right? Okay, so I'm just going to kind of try and draw a good rhombus here. And the area, and I'm sure there's some sort of proof for this. I was trying to think of a good way to explain it to you. That's a times right there. That's a times. It's a dot. It's 1/2 the first diagonal times the second diagonal. And in a rhombus, they're congruent, so it doesn't matter really so much. So that's what it looks like. 1/2 diagonal 1 times diagonal 2. It's like a kite. Pardon me? Yeah, qualifies as a square as well. Yeah, it meets all the requirements. Except I don't know if it always has 90-degree angles. Doesn't always have 90-degree angles, I don't think. I have to think about that one. All right, kite, area of a kite. So a kite looks a little bit different in that the diagonals are not necessarily congruent in a kite. But this side is congruent to that side, and that side's congruent to that side. But fortunately, it is exactly the same formula. So, isn't that nice? Yes?
Isn't a rhombus a parallelogram, so you can see base inside?
It's a good question, but no. And I'll have to find out why. I gotta look into that. That's a good question. I like it. Doesn't work if you do base times height. I don't know why. I like it. I'll figure that out. Yes?
So what are the D1?
The D1 are the diagonals.
Oh.
So diagonal 1 and diagonal 2. The two diagonals. Okay. All right, turn it over. Easy enough. So we're going to work with those. I'm still thinking about Janie's question. I'm pondering. I want to figure it out. Okay. I will figure it out. So, it is a what kind of shape? Rhombus. So we're going to use the distance of this diagonal and the distance of this diagonal. And they're not the same. So how far is this diagonal?
30 meters.
This piece is 30 meters, so that means the whole diagonal is 60, okay? So area equals 60 times this whole diagonal, which is 80.
Couldn't you just do 30 times 40 then?
You could, no, because you only take half of one of them.
Oh.
If you multiply straight across, half times 60 times 80. See what I'm saying? Okay, so area equals 2,400 meters squared. Okay, this one here is a kite. It's still the same formula. They're just giving us this distance here, which is the same as that diagonal right there, right? So it's just the same formula. Area equals 1/2 6 times 14. Area equals 3 times 14, or 7 times 6 you can do in your head. 42.
I'm thinking 6 times 6. I know you're thinking of
Because you can do multiplication in any order, right? So make it easy on yourself. You do it in your head. Do it in your head. Okay? All right. Trapezoid. This is a trapezoid. It has two parallel sides. Area equals 1/2 base 1 times base 2 times height. By the way, I do believe you have to memorize all these formulas. And I probably will make you write the formula down for every single problem that you have on the quiz or test, and then plug in what you know. I haven't decided yet, but usually that's what I do. So 1/2, the base 1 is 6, base 2 is 8, and the height, which is perpendicular to the bases, is 4. Bet we can do this in our head too. What's 6 plus 8? 14 times 1/2. 7 times 4. 28. 28 feet squared. Following order of operations. Don't forget your order of operations when you're working with these formulas, okay? All right. One diagonal of a kite is 1/3 as long as the other. Okay, so I'm going to draw a kite. And I know one diagonal is longer than the other in a kite. So the shorter one is going to be my 1/3 piece, right? And this one I'm just going to mark as X. Well, let me make a kite out of this. So my longer one is X. My shorter one is then going to be represented as what? 1/3 X. Based on the information they gave us. We're going to use what they gave us. And I want to have the same variable so I can solve for that variable. Because they gave me the area here, didn't they? The area of the kite is 0.24 meters squared. What are the lengths of the diagonals? So I went back and I said, all right, one diagonal of a kite is 1/3 as long as the other. That means the shorter one is 1/3 the other one. If you draw a picture. So now we're going to plug it into the formula. Plug in what you know. You know the area is 0.24. You know this is 1/2. You know the one diagonal is 1/3 X and the other diagonal is X. Okay. Is this just all multiply? The parentheses really are irrelevant here, aren't they? I want to make sure you're all aware of that. So I'm going to do it like this. 1/6. Where did I get that? 1/2 times 1/3 is 1/6. Let's get rid of that fraction by doing what? Yeah, let's multiply both sides by 6. I want you to start looking at it like that. It's very helpful in algebra, rather than converting it to decimal all the time. Think about just multiplying by the reciprocal. That'll make that go away. And 6 times 0.24 is 1.44 equals x squared. Oh, what number does that look like? 144, which is a perfect square, isn't it? So maybe you could think like that, right? Number sense. I still threw it on the calculator just to be sure I had the decimal in the right spot, but take the square root of 1.44, what do you get?
1.2.
Right, 1.2. Now, here's what else happens sometimes. The reason I did not want you to convert this to a decimal is because I think it's a repeating decimal, and then you would end up rounding, and then when you divided, you would get a number here that is not a perfect square. So it wouldn't work neatly. So it's better always, if you can, to just do this. Make sense?
Yeah.
Okay. Now the question was, what are the lengths of the diagonals? Well, I'm going to say diagonal 1 is 1.2 meters. I found that right there. Diagonal 2 is 1/3 of that. So you could, if you had to go on your calculator and do 1.2 divided by 3, which is 0.4. Make sense? Okay. The front of a decorative chest is a trapezoid as shown. Find the area of the front of the chest. And I looked at that and I'm like, really? That's all you want us to do with this problem? It's true. We just have to find the area. Area equals 1/2 base 1 plus base 2 times the height. And we're going to plug in what we know. I don't know the area, but the bases here are what? 18 and 12, right? Times the height, which is 20. Half of 30 is 15 times 20. What's 15 times 20? 300. Inches squared.